Next chapter, scale drawing and angles of elevation and depression. Scale drawing. We talked about ratios and proportions, and we said that a ratio is basically a relationship of two or more items, and that a proportion is basically two equivalent ratios. Scale drawing is all about proportions. A map is a very good example of scale drawing, which is just a drawing that is either larger or smaller than the real thing it represents, but it's still in proportion to that thing. For example, this map of Hawaii is much smaller than the actual Hawaii. But even though the map is smaller, it's still proportional to the real Hawaii. And it even has a scale on it to show the relationship between the two sizes. This is an example of what we call a linear scale. This means that 5 centimeters on the map represent 9 miles on the ground. We could also have a statement scale, like 1 centimeter represents 40 kilometers. Or a ratio scale. Usually in ratio scale, the units must be the same. And so for 1 centimeter represent 40 kilometers, all the units must be in centimeters. And so we shall have 1 to 4 million. We can have that in form of a fraction. 1 centimeter over 40 kilometers, or 1 centimeter over 4 million centimeters. For our map, it shall be 5 centimeters over 9 miles, or 9 miles over 5 centimeters. Suppose we want to know how many miles it is from Mauna Loa to Hilo. We can set a proportion to work that out. The ratio that we already know is 9 miles over 5 centimeters. Now, we only need to set that equal to an equivalent ratio that has the unknown distance. Because we have the map, we can use a ruler to measure how many centimeters it is from Mauna Loa to Hilo. It looks to me like 20 centimeters. And so the bottom number of the equivalent ratio is 20 centimeters. And the top number is the number of miles, which is unknown. We put an n. So to solve for n, we do our cross multiplication. N times 5 is 5n. That is equal to 9 times 20. To get n, we divide by 5, and we get 36 miles. It's that simple. Next, angles of elevation and depression. You are looking up at something. This is called the angle of elevation. The angle of elevation denotes the angle from the horizontal upward to an object. So the angle is above the horizontal. Or maybe you are looking down at something. Straight ahead is the horizontal. And if you are looking below or downward, this will denote the angle of depression. And now we have two parallel lines and a transversal cutting across each line. It should be rather obvious, really, that the angle of depression is alternate to the angle of elevation, and so they are equal. Let's take an example. A bird is sitting on top of a post that is 8 meters tall. The bird spots a worm on the ground at an angle of depression of 30 degrees. How far is the worm from the base of the signpost? That's the signpost and the bird, 8 meters high, and sees a worm, and the angle of depression is 30 degrees. So how far is the worm from here? This can be depicted by a right-angled triangle. This is the horizontal, and this angle is 30 degrees. The angle of depression is equal to the angle of elevation. And so we find x. By drawing this illustration to scale, we can be able to find the distance from the foot of the post to the worm.
applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret, or the biggest piece of advice, is get help early from as many people, and there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.